I went through your the quality management. So far we've covered time management, cost management, risk management, stakeholder management, scope management. So another very important area of project management is project quality management. Um, so most of the time we don't give the due place for quality, and at the end because because of quality issues there's additional costs, there is impact on timeline, scope may change. So if you don't give the right to quality, you may end up in a trouble at the end of the project. So it's important that the right priority, right focus is given to quality throughout the project life cycle. Right? So initially, when we started, when we give the introduction to project management, we spoke about this iron triangle, right? Um, can can someone tell me what we discussed with regard to iron triangle? So we said we have in iron triangle we have scope, time, and cost. If we do a change to one of these three areas, one or other two will have an impact. For an instance, if I increase my scope, my timeline would be increased as well. My cost can be increased as well. Sometimes both my timeline and cost can increase. Sometimes we will add more resources, add more people, do work in parallel and meet the same timeline with this increased scope also, but cost for sure will increase. Right? In the same way, if you reduce the cost of the project, if you say what you plan to do in $1 million, if you say I'm going to do in 500,000, you won't be able to deliver the full scope that you planned earlier. Also, your timeline may increase. Right? So, so far we spoke about these three variables with regard to iron triangle. But one of the very important things in the iron triangle is quality. Quality sits in the middle of the iron triangle. Right? So when we spoke about all this, we said considering quality is a constant. Considering you're not changing the quality, increase of scope would have impact on cost and time. Considering quality is a constant, that we don't change quality, if we reduce our budget, we would have to reduce the scope as well. If you reduce our budget, we might have to add more time as well. Right? So this is all considering quality remains a constant and ensuring the same quality standards. So quality plays a main role in project management in general. So what is quality? What do you think is quality? Can someone tell me? We speak about quality day in, day out. Even if we go to buy a particular merchandise, we would say this is a quality product, this is not quality, likewise. But what really is quality? What do you think is quality? Now, what do you think is quality?
I guess the standard of how well it's done.
Standard of how well the
product is completed or
how well the
I guess.
completed. Okay. That's one way to look at it for sure. Ashin, what do you think is quality? Ashin? Churchill, what is quality for you?
As Naif said, the standard of the end product.
Okay. Anyone having any different definitions for quality? Dimitri, what do you think?
Morning, Pasindu. Quality is the standard demanded by the client.
Standard demanded by the client.
Yes.
Okay. Good. I'll come back to that in a minute, Dimitri. Shashi, what do you think is quality?
Good morning, Pasindu.
Good morning, Shashi.
Quality, I would say, how well some product or project satisfy the requirements.
How well?
Maybe the degree to which it satisfies your requirements.
Okay. I like the definition, to be honest. So with regard to the standard, right? Okay, Dimitri, your group activity is to build a house, right? Dimitri?
Yes, Pasindu. Yes.
In that sense, how would you measure quality? Like, if you are looking at, looking at it from a customer point of view, how would you define quality there?
So from a house building point of view, there is like a minimum standard set by an authority about how a house should be built, what standard it has to meet, and there is also the client's requirements.
Okay.
So how well we meet those requirements is quality. So if the client demands something, our ability to deliver that without any variation or like a, I don't know, normally you call it an error, but
Okay.
in a house building case.
Yeah. Got it. So now I'm clear. I'm more clear on what you said earlier, Dimitri. Sorry, I had a different viewpoint initially, but yes, like most of you guys said, quality is the degree in which, a project or a product fulfill the requirements, right? So quality is very tightly coupled with scope, right? We tell quality as the degree to which the project or product fulfills the requirements. So it has a very tight link with the scope because the requirements comes from the scope, right? For an instance, now let's take example. You have a requirement, a customer has a requirement to build a web application which retrieves data in 10 seconds. So when you type a query and when you hit enter, it retrieves the data in 10 seconds. Now, what if you do your program to retrieve the data in 1 second? Do you think it's quality?
I guess it would improve the quality provided it supplies exactly what's required within a shorter time frame.
Okay. So you think it's good quality? It's a characteristic of a good quality that you exceeded the client expectation.
Yeah.
Okay. Anyone else having different viewpoints? Again, like, you know, I would say it's situational. But for me, quality is delivering what is promised. So if you promise the application to return the results in 10 seconds, it should return the results in 10 seconds. If you put additional effort, energy and money, cost, and get it done in 1 second, for me, it's gold plating, right? Yes, sometimes, like, you know, you don't really, like, you know, if you say 10 seconds, you might do 9 seconds, 11 seconds, slight variations. But like, you know, if you are spending a lot of energy to satisfy customer, going above and beyond the scope requirement, that's gold plating, because that's effort, that's money for your company that you would invest in as well, right? Same way, like, you know, if a customer wants a 2-bedroom apartment, we won't deliver 3 bedrooms, right? It's gold plating. It's known as gold plating in quality management aspect. So ideally, quality is delivering what is promised, nothing more, nothing less. Now, in terms of project management, we are looking at quality management, right? So when talking about quality management, that includes creating policies, procedures on how you're going to ensure quality, how the product would meet the final deliverables. Also, what kind of monitorings, what kind of measuring mechanisms you're going to implement in order to measure, quantify quality. That whole aspect, measuring to monitoring and then to controlling the quality. So when talking about quality perspective, there are multiple areas that we need to look into, right? One is in terms of customer. How customer looks at quality. What is customer's expectation? Am I conforming to customer requirement? So ultimately, the product that you are delivering should meet customer expectation, right? So that's one perspective of quality management. Again, as I stated initially, quality is tightly coupled with scope. So quality is not just delivering end product. It should be built in throughout the project life cycle. For example, when you are gathering requirements, you should have quality built in. Customer might say, I want a 3-bedroom apartment with, like, you know, windows, like, you know, French windows all around the house. But you as a trusted advisor, you as a consultant would need to give your consulting in doing what customer wants. You might need to brainstorm with customer. So these are the advantages of having a house with French windows in like, you know, in all the sides. These are the disadvantages. Have you considered these advantages? We are in a sunny country. You would get a lot of sunlight. It would be difficult for you to stay inside at times. Likewise. So you need to explain the pros and cons, and then, like, you know, you need to ensure that customer understands the requirement and that that is exactly customer wants. Most often than not, when you deliver projects, when you go into blueprint discussions, you realize that customer has something in mind, but it is not really spoken out or explained properly to the business analysts. So it's important that we ask right questions, that we ensure that what the end product is exactly what customer requires. So there are multiple things that you do to ensure this, right? One mechanism is prototype. You would create the end product in rigid form or cardboard, or in a small scale, so that customer can really come and look at it and have a feel for what the end product is. Now, if you look at this apartment building, today you have show apartment concept. Now, 10, 15 years ago, we did not have that concept. Right now, why we have it? Because we've realized most of the time what customer expects and what customer gets at the end of the day are two different things. To minimize that gap, to bridge that gap, we've come up with different mechanisms to give that look and feel before customer commits to the project or the product. So customer satisfaction is a very important part of quality management. And as I said, it should not be just at the end. It should be built in throughout the project life cycle. Second perspective is on prevention, right? Preventing bad quality being released to the customer. Now, if you look at a production line, you have quality control, right? What is QC? Can someone tell me the difference between quality assurance and quality control? Sachini, what do you think is the difference between quality assurance and quality control? Sachini? Did you guys had a late night party or something? You are utterly quiet today for a morning session. Shashi, what do you think is the difference between quality assurance and quality control?
Quality assurance is maybe the process they make sure the quality of the product is met. I mean, the requirement is met.
Okay, good.
Control maybe how well it meets the customer's expectation, or like ensuring how maybe.
Okay. Okay. Good. Hashan, what do you think is the difference between quality assurance and quality control?
Quality control is about fulfilling the quality requirements of a certain product, and quality assurance is how it's made.
Okay. Quality assurance, I think you guys have a good understanding. What is quality control? Yanushka.
Quality control is making sure that like every aspect of your the process in which you're conducting your project is having some sort of quality, like it's either maintained, making sure it's maintained.
Okay. Not the answer I'm looking at, Yanushka. Little different. It's all right. Sudesh, what do you think is quality control?
Quality control is maintaining the quality, predetermined quality.
Predetermined quality. Dimitri, any idea what quality control is?
Quality control is like quality assurance is if you are delivering a product okay, quality control is after you make a product, checking that the quality has met the standards is quality control. It's like a reactive measure. Quality assurance is like a preventive measure. You make sure that your quality is like you set a standard, that is quality assurance. Quality control is checking that you meet that standard. So assurance is preventive, control is reactive. Like
Exactly. So that was the answer I was looking at, right? So quality assurance is ensuring that your final product would meet the quality standards. So that includes planning properly, that includes training your employees on the jobs they are doing, that includes designing it properly, that includes proper maintenance of your machines, which is like, building these equipment and all that. But when it comes to control, it's to ensure that non-conformance products or bad quality products are not released to the market. So you observe, you inspect, and you if there's something of bad quality, you would stop sending it to the market. So as Dimitri said, quality assurance is more proactive, it's a more preventive measure. Quality control is a more reactive approach. Right? Again, any project or any company, any operation would have to have both of them hand in hand in order to balance it out. You don't do 100% quality assurance. You don't do. We will talk about how to optimize quality in a little bit, but prevention talks more about how you plan properly, how you design it, how you build it. So prevention talks about quality assurance in building your project, in delivering your project or building a product. Then third perspective with regard to quality management is management responsibility. So management also has a responsibility in terms of meeting quality, in terms of ensuring the right quality is met. On one side, it's to deliver exactly what is promised, nothing more, nothing less. If you continuously deliver something more than what you promise, you as a company would end up losing. Then the other part of management responsibility is to ensure you have the right team, the right balance of skills within the team, right trainings, right motivation to do the job, and to ensure that total quality is built in to the product or the project. So that's in terms of management responsibility. And finally, the fourth perspective of quality management is continuous improvement. Today, what we consider standard, what we consider sufficient would not be enough in in a year's time or 2 years' time. When you look at purchasing a car 10 years ago, you would probably look at does it has good fuel economy? Can it take me from A to B? That's it. Now you would look at a lot of other features also. You would see if your car has cruise control, if it has tire pressure gauge, if it has X, Y, Z other features, right? So your requirements constantly grows. With that, your demand increases. With that, the expectation increases. In order to meet these growing expectations, growing demands, you need to have continuous improvement. It's not just in terms of functionality, it's not just in terms of giving more to the customer, but it's also how you're doing it, right? Seeing efficient ways to do it, seeing more cost responsible ways to perform a certain task, adapting more traceability methods to ensure that you are meeting customer requirements. So we would talk about that also in a little bit. But one example I can give with regard to my organization, CAMSO. So sometime back, we launched this program called CCM. That refers to CAMSO critical mass, right? So as an organization, what we do is we deliver tires. We build tires. We manufacture tires, right? One problem we had is in terms of traceability. How you're going to ensure the quality is made, how you're going to trace the ingredients, how you're going to trace which plant it is manufactured and all that. So we launched a project to ensure traceability from inception to completion. It's part of our continuous improvement journey, right? So whole idea is if you find a product which is not meeting the right standard, maybe like a customer complaint through a warranty claim, we would be able to trace where the tire was built, from whom we purchased the raw material, where the recipe was done, how long it was stored in a warehouse, which warehouse it was stored, how did it was how was it transported to the country of destination, all that. So we could look at the batch which it was produced and then to examine, are there any other defect products? Are there any other issues with the same batch? If so, we can recall the batch without revealing it to the customer, without customer complaining, more proactive measures. So a lot of companies today have this continuous improvement built in to their daily operations. So it's a very important aspect of quality management. Again, when you are delivering something, how you can deliver it more efficiently, how you can use your resources more efficiently. You need to think all this. So that is a continuous improvement in the project life cycle. Do you guys have any questions with regard to these 4 perspectives of quality management? Is now all clear, or are there any questions?
Clear.
All right. Next, we would talk about grade. Okay. What is quality? We spoke about now. What is grade? What do you think is grade? Madhushan, what is the difference between quality and grade?
Quality means the standard of a good, and grading means it's like different types of standards.
Different types of standards.
Yeah.
All right. So we said quality is the degree to which project or the product meets customer requirements or requirements in general. So what is grade? What do you mean by a different standard? Sachira, maybe you can tell me. What is grade for you?
Grade is a category assigned to deliverable, like having same functional use but different technical characteristics.
Okay, good, good. You're somewhat there. A category assigned to a product, same functionality, different technical characteristics. Good. Very good. Anyone having any different ideas, different definitions? So I actually like Sachira's definition, right? It's quite closer to what I was expecting. So as we spoke earlier, quality is the degree to which the project or the product meets or conforms to the requirements of the customer or the expectations of the project. So in terms of quality, we look at conformance to the requirement. When speaking about grade, as Sachira mentioned, it's the same functionality delivered, but with different technical characteristics. So you assign categories or ranks to products that has the same functional use, but made out of different technical characteristics. A very good example is iPhone, right? So iPhone, you have iPhone X, you have iPhone SE, right? Both necessarily looks at almost same functionalities. Both can take a photo, both can make a phone call, both has FaceTime, with both you can read your emails. So in terms of functional use, both pretty much does the same job. But if you look at the technical characteristics, the built features of the two products, they are different, right? For one, you would use Gorilla Glass. For the other, you would use normal display. One you would have Retina, the other you would have normal IPS displays. One would have more memory, other would have less memory. So technical characteristics are different in these two products, making one more affordable, making one more less affordable, right? But in terms of functionality, they both do the same thing. So grades are assigned to these different categories or different ranks of products which serves the same functionality with different technical specs. Clear? Any questions on this? Okay, let me ask you another question. Would you accept a low-grade product? Would you consider purchasing a low-grade product?
That would depend on the scenario or situation, I guess.
That would depend on the situation. Good answer.
Yeah.
Politically very correct. Yanushka, I'll change the question a little bit for you. Do you think a low-grade product would have high quality?
Yeah, possible.
Okay. Would you like to explain how a low-grade product can have high quality?
So a low-grade product would just mean that it has less functionality, right?
The technical characteristics are different,
Yeah.
but Functionality wise, yes, same
It
pretty
would
much.
be the same. So if you're looking at technical characteristics wise, then that portion, like the quality could still be high.
Exactly. Anyone thinking differently, thinking that low grade cannot have high quality? Does anyone here thinks that low grade can't have high quality, or that low grade is not acceptable? So no, as Yanushka rightly said, low grade can have high quality, right? And as Naif said, yes, sometimes based on the situation, you might opt for a low grade product, right? So grade and quality are two different things. Uh, Low grade is still very much acceptable, not a problem, but low quality is not acceptable. So in terms of quality, what you expect is the standards, the expectation, the requirements to be fulfilled. If those are not fulfilled, it's considered as low quality. As Yanushka rightly said, in a low grade product, you would have a certain toned down technical spec. As I said, maybe for iPhone, instead of a retina display, you would have an IPS display. Instead of 32 memory, you would have 16 GB memory. If you are conforming to that requirement, that low grade product is of high quality. If you're not meeting those requirements, then it is of low quality. So low grade is acceptable, low quality is not acceptable. Clear? Any questions on this?
No, all good.
All right. Next, we will talk about accuracy and precision, right? With regard to quality management, accuracy and precision are two very important concepts. What do you think is accuracy? What do you think is precision? Today I'm getting you involved a lot. I'm asking too many questions, right? Sudesh, what do you think is accuracy? What do you think is precision? Anyone who has done archery as a hobby?
Accuracy is how closely it's correct.
Okay.
And precision, that I have no idea.
All right. I like your answer with regard to accuracy. Thank you for that. Shamit, what do you think is precision? What do you think is accuracy?
Let's say if you look at a target, what you want to achieve, how closer you are to it could be precision, and probably how, yeah, that's what my thinking is.
How close you are to the
target.
target is precision. Did I get you right, Shamit? How close you are to the target is precision?
Yeah.
Okay.
Yeah.
Anyone having different thoughts? Shehan, what do you think is precision? What do you think is accuracy?
Accuracy means something to when it comes to aircraft component, they
Okay.
give specific tolerance when you are designing something.
Okay.
So if you develop that product within that tolerance, that means you are
Accurate.
accuracy. Yeah.
Okay. What about precision?
Precision means if you compare several products with the original one, the one you are designed,
Okay.
and how close to that designed one.
Perfect. Perfect. I like your answer. I like your example also. So yes, as you said, accuracy is how close your value is with regard to the target, or how close it is to the expectation. That's accuracy. Uh, Precision is how similar the measurements are. For an example, when you're troubleshooting something, like, you know, let's say you're troubleshooting a program. Uh, if you get errors everywhere, that means it's not precise. You have, like, you know, a lot of errors everywhere. But if constantly you are getting an error in a particular module, particular area, that means you can precisely say that you have a problem in this area. If you fix it, you can be accurate. So precision is a measure of similarity. Accuracy is a measure of exactness, right? How closer you are to the target is accuracy. How similar your values are to one another is precision. So if you look at this, this example, right? Now here your target is this bullseye. As you can see, you have not been able to meet this bullseye pretty much. Like, you know, it's everywhere. So this is low accuracy in general and low precision, because it's everywhere, it's scattered across. But now if you look at this example, where in terms of accuracy, you're nowhere, right? You're far away from accurate. But in terms of similarity, everything has landed in this area. So it's precise, high precision, low accuracy. If you take this example, most of the time you are within this range. So in terms of accuracy, you are having a high accuracy. But in terms of precision, you are scattered across. So it's low precision, high accuracy. And if you take this example where everything has landed in the bullseye, you are highly accurate, you are highly precise. Similar as well as exact. Any question on application of these theories, accuracy and precision? Yanishka, all good with accuracy and precision?
Yeah, Pasindu, all good.
Let's move on. So now, up until now, what we did is we looked at quality in general. We looked at some of the key concepts of quality. We looked at the 4 perspectives of quality management in terms of management aspect and all that. We looked at accuracy and precision. We looked at quality assurance and quality control. Now we would talk about quality management process. Now, in project management, how we are going to ensure quality? There should be a process to manage quality. So, quality management process looks at 3 main aspects, 3 main sub-processes, right? As in any project management knowledge group, be it cost management, be it schedule management, be it stakeholder management, be it risk management. First step is planning. Right? So in quality management also, first step is to have a quality management plan. So planning quality management is our step number 1. Once you do the plan, then second step is assurance, right? as Dimitri said, assurance is preventive. It's more proactive. Performing quality assurance, building quality in, that's our second step. Once you do your quality assurance, our third step is control. Now, with regard to other knowledge groups also, control is the last knowledge area in all of these sub-processes. When it comes to cost, we looked at cost control. When it comes to time, we looked at time control. When it comes to stakeholder management, we looked at stakeholder control. So third step is controlling, quality controlling. Right. So today we will talk about all of these three areas in detail and see what tools, what techniques you can use in doing these activities. So let's move on to quality management planning. Plan quality management. This provides guidance and direction on how quality will be managed and how quality will be validated throughout the life cycle of the project. So as I said earlier, how you're going to build quality when you're gathering requirements. How you're going to build quality when you're designing your prototype. How you're going to validate quality of the end product that you're going to deliver to the customer. What is the quality for the project? What is the requirement? What is promised? How you're going to ensure the quality standards, the expectations, or the desire of the customer. So planning all these aspects is the process of planned quality management. So we did not went into detail of inputs, tools and techniques and outputs of other sub-processes, but because of the importance of quality, I've taken some time to go through the inputs, tools and techniques and outputs of each of these three areas: planning, assuring quality, and then finally controlling quality. So when it comes to quality management plan, when it comes to planning quality management within your project, what are the inputs? You would look at your risk register. Why you look at your risk register? To understand what potential risks you have, which might impact your project. If your timelines are not met, your customer expectations might not be met as well. If your scope is not met, your customer expectations are not met at the end as well. So risk register becomes a very important input to plan quality management in order to understand the risks, in order to ensure that there is a mitigation strategy, or in terms of risk materialization, a contingency plan. Right? So risk register is the first input which goes into quality management. Then your enterprise environmental factors. What are enterprise environmental factors? Your team, how you're going to build the project, your environment, your work place, all that. Those are enterprise environmental factors, your standards, all that. Third very important output is scope baseline. Scope baseline is important. Why? Because it would be the baseline for the quality as well in terms of expectation. Customer expects a house with three rooms with bathroom fittings from American standards, with floor tiles from Russell. You have to meet that expectation. That's your scope baseline, right? So scope baseline will give input to managing quality, to describing the expectation of the customer. Fourth item is requirement documentation. Why do you think we need requirements documentation and scope baseline, both of them? Or rather, what is the difference between requirements documentation and scope baseline? We discussed this with regard to scope management. Can someone tell me now? Vidhu, what is the difference between scope baseline and requirement documentation? Vidhu? Isuru, what do you think is the difference between requirements documentation and scope baseline? Guys, can you hear me?
Yeah, Pasindu. Yeah, I think requirements documentation is like what the customer wants.
Okay.
Whereas the scope baseline is the agreed requirements that you decide to provide from the project.
Perfect. Thank you for that. So as Yanushka said, requirements documentation is the requirements that you obtain from the customer. Scope baseline is the agreed scope that you're going to deliver within the project. Not all the requirements might be scoped in. So scope baseline would probably be a subset of your requirements documentation, right? So why requirements documentation is important for plant quality management is to understand the pipeline, is to understand the customer expectation on a long-term strategy. And then when you build quality in, you need to ensure that you at least keep provisions to incorporate this additional requirement at a future stage. So that management plan as an input. Then fifth input is your organizational process assets. What are organizational process assets? Any organization would have templates. Any organization would have processes, procedures, workflows, approval mechanisms. These are your process assets. It becomes an input for plant quality management. Why? Because you can look at similar projects in the past. You can look at templates which was done for similar projects, and you can leverage them rather than reinventing the wheel every time you do a project. You can leverage what is done already. So that becomes an asset or an input to plant quality management. And finally, stakeholder register. Now, last week we discussed about the stakeholder register, and it is important. Why? Because we know who are our stakeholders, what are their expectations, what kind of an interest they have in the project. Are they for the project or against the project? Are they resisting or are they promoting? With all that, you can meet their expectation. So these 6 are the inputs for plan quality management. Any questions on this? I think it's very clear, but if you have any questions, please feel free to ask. All right. We'll move on to tools and techniques which are used in plan quality management. One is what is cost benefit analysis. Cost benefit analysis is to understand the amount of cost which is required to build something, or amount of cost which is required to incorporate a certain functionality versus the benefit you're getting out of it. It's important to perform that cost benefit analysis. Otherwise, you might invest a lot of money for a benefit that is not worth of having. So cost benefit analysis is one tool which we use for planning quality management. Second tool is cost of quality. In a very small time, we come back to cost of quality. So basically, cost of quality looks at what kind of cost you are incurring in order to build quality. Then you have 7 basic tools of quality. We will talk about this also. With regard to 7 basic tools of quality, you have flow charts, you have Pareto diagrams, you have fishbone diagrams, you have scatter graphs, all that. So we will talk about it also. Then you have benchmarking. What is benchmarking, guys? Sachini, what is benchmarking? Sachini? Shamit, what is benchmarking?
How you compare your position related to a similar product?
Yeah. So especially when you do benchmarking with regard to building something new, or when you are doing something for the first time, or when you are competing with someone, you benchmark. So probably in your industry, Boeing and Airbus would be competing with each other. So they would benchmark different products, and they would build similar in their phones, Samsung and iPhone. iPhone had certain features, Samsung benchmarked iPhone, they wanted to get those features. Now it's at a stage where, like, Samsung has more features than iPhone even. So benchmarking you do when you're doing something new or something competing with another party. Then you have design of experiments. That's also a tool which you use for planning quality management. Through a set of experiments, through designing a set of experiments, you look at how your end product can be delivered. Then you have statistical sampling. Again, a tool used for quality management. You can't sample everything, so you take statistical sampling. You take a random bunch, or with regard to a certain batch, you would take certain iterative numbers, and then you do sampling. So these are the main tools and techniques which are used for planned quality management, and we will talk about them in detail also. The important ones, we will talk about them in detail. So now we need to talk about cost of quality. What is cost of quality for you? Churchill, what is cost of quality?
How much you spend for the quality assurance and quality control in the project life cycle.
Yeah. So when you're doing a project, activities you do to ensure that you are delivering a product which meets customer expectation is cost of quality. So what are the activities you would do when you're building a house that would fall under cost of quality? Dimitri, what are the activities which would fall under cost of quality when you're building a house?
Maybe employing a quality assurance engineer, budgeting for audits.
Okay, good. So now with regard to building a house, what you would do is, now before you do piling, you would take a soil sample and you would send it to your structural engineer to ensure or to understand the characteristics of that soil, to understand how deep you need to pile. That is an activity you do to ensure quality of the end product. Then you would have your architect or your structural engineer visiting, inspecting, sampling the products that you are bringing into the site. Whatever items you are bringing into the site, maybe you would have to send samples upfront. You would have to validate it with the customer. Once the customer gives the approval, you will bring the bulk of the items. So that's to prevent bad quality coming into the site. As you said, deploying a quality assurance engineer and doing quality assurance tasks, appraising the product or service, meeting to the conformance of the requirement. So all of these are costs that you incur in order to build quality. Now, I hope you all are clear with regard to cost of quality. It's basically prevention cost and appraisal cost. Right? When it comes to cost of poor quality, what is cost of poor quality? Naif, what do you think is cost of poor quality?
I guess the complications that you come across due to poor quality control.
Complications that would come across because of poor quality control. Okay. Sachira, what do you think is cost of poor quality?
Appraisal cost and prevention cost.
That's cost of quality, appraisal cost and prevention cost.
Yeah.
So when it comes to cost of poor quality, what is cost of poor quality? Yanushka, what is cost of poor quality?
It's, I guess, the cost incurred to fix problems, maybe things that went wrong.
Okay, good.
So corrective action.
Sorry, did you say preventive actions?
No, I said corrective actions.
Corrective actions, yes. So yes, cost of poor quality quantifies the negative outcomes due to waste, deficiencies, and defects. So if you build something which is not conforming to the customer requirement, you would have to redo it again. And that requires money and time. That's cost of poor quality. The corrective actions, like you rightly said. When it comes to cost of poor quality, you can look at it from three perspectives. Cost of internal failures, cost of external failures, and cost of exceeding requirements. What is cost of internal failure? Now, I was with MAS before, right? So when we produce merchandise, we have a quality control mechanism where for any batch we would take a random sample. We would, like, if let's say if the batch is 100, we would take 10 maybe, and we would look at items. We would inspect. Are the threads done properly? Are the buttons stitched right? All that. And then if you realize something not right, we will discard it, destroy it. And we will have to put another piece for that batch. So that's an internal failure. Customer didn't know, but you had to destroy something because it was not meeting the requirements. Then you have cost of external failures, warranty claims. Now, you buy a washing machine, you get a warranty of 2 years. After 1 year, it breaks down. You go to the agent who sold it, you claim it, warranty claim. That's what happens to the company. Company would have to take back that item, and customer would be given a new item or would be repaired at company's expenses. So that's a cost of external failure, right? Customer get to know about it, customer complains it, and then it gets replaced. Then third cost of poor quality is cost of exceeding requirements. Now we are doing a project which has some construction activities in that project, and we asked the vendor to deploy trunking with a certain microns. But in order to do well, in order to exceed our requirements, they've increased the micron level, and they've done something of a higher micron level, which is an extra cost for their company. But for me, whether it has 10 microns or 100 microns, it serves the same functionality. So it does not add value to me. On the other hand, it costs more for the vendor. So that's a cost of exceeding requirements. So as I rightly said in the beginning, quality is delivering what you promise, nothing more, nothing less. So if you exceed the expectations or requirements, that's a cost that you are spending for no reason. So that's also a wastage. So that can also be considered as a cost of poor quality. So with regard to cost related to quality, generally most commonly looked at two items is cost of quality and cost of poor quality. But there is something very important than both of these. That is cost of loss opportunity. What is cost of lost opportunity? That is basically the revenue loss because of a loss of a existing customer or a loss of a potential business or a loss of a business growth that that has arisen because you fail to deliver on time or deliver according to the expectations, right? Okay, so Jeremy also told me that PDF is not uploaded to the module yet. I will make sure that this is uploaded by within the day today. When you deliver something bad or when you deliver something of low quality, customer would not recommend you to another client, right? So that's a cost of a loss opportunity, right? That's a higher loss than actually correcting it, right? That's why companies like, most of these reputed companies have this warranty claim process that customer at the end would not suffer due to the bad quality, right? They would get it, they would get the functionality that they expected for the duration that was promised, right? So because of that, they have all these warranty claims and all that. So cost of loss opportunity is very important with regard to quality. If you don't deliver high quality, if you don't deliver right quality, people would not recommend you to another business. You might lose potential business or potential revenue. That is what we speak when it comes to cost of loss opportunity. Any questions on these areas so far? Is it clear? Okay, we'll move on. Now, I said at the beginning that we need to optimize cost of quality. So, how can you optimize cost of quality? You have quality assurance here, okay, in the green arrow. This is my quality assurance. Sorry about that. So this is my quality assurance, cost for implementing quality. And this is my cost of rectifying defects. If you have low quality, very bad quality, quality assurance cost is less, but rectifying quality control, or fixing the defects, cost of poor quality is high, right? If you put a lot of quality assurance mechanisms, okay, if you put a lot of effort and energy into assuring quality, you would spend a lot of money on quality assurance, implementing quality, but that would mean that you would get lesser defects. So you need to spend less money on fixing the defects. So you need to see the balance. You need to see the see the blend. So where these two graphs cross, that is the optimum point where you need to maintain cost of quality. So in terms of cost of quality, cost of total quality, this is your cost of total quality. When you have low cost of implementing quality and high cost of rectifying defects, your total cost of quality is high. As you implement quality, your rectifying defects, cost of rectifying defects will go down. So will your total cost of quality. It will also go down. At one point, it would reach the optimum level where the total cost of quality is lowest. Beyond that point, if you spend more money implementing quality measures, you will spend more money on implementing quality. That would mean you would spend less money on rectifying defects, but overall cost for quality, overall cost of quality will go high. So you need to balance it out at this point. So this is the point that where you should target when you are delivering a project or a product. You should not try 100% quality. You should not try 0% quality either. You need to have the right balance. Does this make sense to you? Are there any questions on this? Madhushan, all clear?
Yeah, person. Okay.
All right. So in other words, when you're delivering a project or a product, it is expected that there can be defects, but you should have it at a manageable level so that the amount of money you spend on fixing those defects makes sense and is justified. So if you look at this point here, there is some money spent on implementing quality. There is some money spent on rectifying defects. So this does not mean that there is no defects in the product. There are defects, but this is a good quality level that you can maintain. If you look at here, even though you have very high cost with regard to implementation, still it does not mean there is zero defects. There can still be one or two defects, but having that many less defects at this cost doesn't make sense. So that's why we opt for this level. Okay, good. Let's move on. So now we talk about 7 basic tools of quality. So with regard to quality, there are 7 basic tools that you are looking at. One is checklist. Okay. I'm not going to go into detail of each one, but they are very straightforward. These are tools which can be used to plan quality management. Checklist gives you a set of items to ensure that you have done them. So pilots do this before a takeoff. When you do a maintenance activities, you go through a checklist to ensure that you have not missed any critical item. So checklist helps you track the things that you do. Also, it helps you not to miss an important step in your set of items that you need to do. Second one is fishbone diagram. This helps you understand root cause, right? It also helps you segregate your problems into different areas. Run chart. This is a tool that can be used to understand the trend, same as Pareto charts. Flow charts explains the process flow of the process in which you manufacture or you produce a certain product. Histograms, scatter diagrams, all of those gives you a statistical reasoning as to how your product behaves in that sample. So these are the 7 basic tools of quality that is commonly used in plant quality management. Then we come to quality management outputs. So when you do the plant quality management, so we spoke about inputs, we spoke about 6 inputs, we talked about tools and techniques that we are using for plant quality management. Now it's outputs. So main output of plant quality management is your quality management plan. This talks about what are the measurements, how you're going to measure it, what frequency you're going to use, who's responsible for what, all that. Then your quality metrics. What are the metrics that you're going to use to ensure quality? How you're going to measure them. Third one would be quality checklist. A checklist in which you can follow in order to ensure that the steps are done properly. Process improvement plan. Now, sometimes you would realize as part of cost management plan, I'm sorry, this is, sorry about that. As part of quality management output, you might have a process improvement plan. And finally, you would have updates to project documents, which includes project plan and all that. So once you do your planning, you go to your second step. What is the second step? Quality assurance, performing quality assurance. Right. So performing quality assurance, it is the process that facilitates improvement of quality processes, right? Building in quality for the product or the project. With regard to inputs, your quality management plan becomes the main input for performing quality assurance. Quality control measurements, quality matrices, process improvement plans, and project documents. Outputs here becomes input for performing quality assurance. What are the tools and techniques you're going to use for assuring quality? One is quality audits. Audit can be reactive as well as proactive. So audits can be used to assure quality also. While you are doing something, you audit to see if you are doing it the right way. Rather than changing it at the end, you change it at the middle. Advantage is you would have spent lesser money on the change. So quality audit is one main tool that you would use for performing quality assurance. Second one is process analysis. You would analyze your process. For an example, if you are manufacturing an aircraft tire, what is the process in which you are manufacturing the tire. You would analyze that process. You would analyze it to see the inefficiencies in the process. You would analyze it to see improvements that you can do to the process. You would analyze it to see what quality implications are brought in by the process. So based on that, you would do process improvements. Third tool and technique which we would use for performing quality assurance is plan quality and perform quality control tools. So as part of quality assurance, you need to plan the techniques for quality control also. So that planning becomes a part of quality assurance. Right? Ultimately, you are preventing something bad from reaching the customer. So planning quality and perform quality control tools is also becomes a tool in your quality assurance tools and techniques. What are the outputs of perform quality assurance? Project management plan updates. Your project management plan may get changed as an outcome of a quality audit. For an example, when Dimitri's group is building their house, when they're doing the quality audit, the architect would come during the audit and say, okay, you built the wall in the wrong place. What would happen? They will have to bring down that wall. They will have to build the wall in the right location. What is the impact for the timeline? Timeline would get shifted. Timeline have an impact. So project management plan will also be updated as part of a quality assurance audit. Change requests. When you do audit, when you do an inspection, you might come up with change requests. Change request and audit findings are two different things. What is the difference between the two? Can someone tell me? Naif, what do you think is the difference between a quality audit recommendation and a change request?
Change request could be something which comes from the client itself.
Sorry, Naif, you were not very audible.
The change request can be something that comes from the client side.
Something that comes from the client side. Okay.
So which would change the basic scope of the project.
Okay, which would change the basic scope of the project. Why client side?
Because they might want something else added to their project as it is, or depending on like the cost requirements, they might want to change or remove something.
Okay. Yeah, but change request does not necessarily comes only from the client side also, right? Sometimes change request can come from the vendor as well. For an instance, you might agree to do something in a certain way, but when you're actually doing it, you would realize that it's not technically feasible to do it. So you would go to the customer and tell, hey customer, you know what, I agree to do it this way, but technically it's not feasible. Or you might say, hey Mr. Customer, I agree to do this, At that time, we used to get this material, but now with import restrictions, that's not coming to Sri Lanka. So we don't have a material to do this. Because of that, I can't perform this task as per your request. Instead, I can do it with this material. So that's a change request from the customer. Change request from the vendor, and then customer and vendor would have a negotiation and will come to a conclusion. So that change request can happen from both parties. But as you rightly said, Naif, change request is something additional to the scope that is agreed. It's additional, or it's a change basically to the scope which is agreed. Whereas audit recommendation is it's a fix that you are doing in order to confirm to the requirements that was promised. So audit looks at from a conformance point of view. Change request looks from an enhancement point of view. Sometimes when you inspect, customer would say, okay, it might be better if you have this instead of that. And then he would say, okay, what is the additional cost? I'll bear it. Let's do it that way. So those are change requests. Audit findings are to say, to confirm to the initial scope. Another output would be project document updates. As I said, now when the project plan gets changed, it is a project document, it gets updated as well. Sometimes organizational process assets like templates, like tools which are used can also get updated. So organizational process assets can also be updated as part of perform quality assurance outputs. Any questions so far? So we've covered planning quality management and performing quality assurance. Any questions? Okay. If you don't have any questions, we can go to the last section of our today's session, which is quality control. Okay. So what is quality control again? Can someone tell me what did we agree as quality control? Shamit?
Ensuring that bad quality products are not released to the market.
Exactly. In ensuring that bad quality products or poor quality products are not released to the market. Identifying the causes of poor quality and validating the project deliverables and work to meet the requirements is the activity of quality control. So when you look at quality control, there are two aspects. One is to ensure that bad quality is not released to the market. Second item is to understand the reason behind bad quality and to take corrective action not to repeat that same mistake. So as for the other process, we will look at inputs, tools and techniques and outputs of quality control. What do you think are the inputs for quality control? Now, we spoke about planned quality management, we spoke about quality assurance. So for quality control, what would be the inputs? Quality checklist, right? The checklist becomes an input for controlling quality. So you can go through one at a time to ensure that each step is met. Quality matrices. What are the matrices that are agreed within the projectable product so that you can measure the performance with regard to quality matrices? Project management plan. When talking about project management plan, it's not just a Gantt chart with a timeline. It's your entire project management plan, which includes quality management, stakeholder management, scope management, time management, risk management, everything. Why you need it? Because quality control may have an impact or may have to adhere to the requirement management plan, stakeholder management plan. So that becomes an input for your control quality scope. Then work performance data. What is work performance data? Can someone tell me what is work performance data? Shashi, what is work performance data?
Work performance data.
Sorry?
Not pretty sure.
All right. Okay, not a problem. Isuru? Ashay, what is work performance data? Churchill?
The observations and the data from the process.
Yeah. So data gathered from producing or within the life cycle. How much time you spent on this? How, like, you know, if you are manufacturing something, what was the thread used? At what, like, you know, in a garment, how many threads are in a particular cloth? What kind of thread is used? What is the strength of that thread, how much time was spent on that particular garment, all that. So that is work performance data. That is important in order to understand effort spent, energy spent, material spent on that particular finished good. Approved CRs also becomes an input for quality control. Now, project management plan or your scope baseline would have something, but you might have a approved CR contradicting. So, approved CR would overrule your scope baseline. So, based on that, you would have to take necessary measures. Then finally, your deliverables, your end product. That also becomes an input for controlling quality, because that is the item that you're looking at, that you're observing in order to ensure the quality.
Pasindu, what does CR stand for?
Change request. Change request. So in the scope baseline, you agree on a particular scope, but as the project progresses, customer and vendor would agree on certain changes. So these changes gets approved, and these approved changes will become a part of your deliverables, part of your scope that you need to deliver, even though they are not in your scope baseline. So those approved CRs, approved change requests, would also become an input for quality control.
Okay, great. Thank you.
No worries. What are the tools and techniques that are used in quality control? So the 7 basic quality tools which we spoke about earlier is used for quality control to understand the trend. Now, if you look at these products, like if you look at a biscuit packet, have you ever noticed it saying plus or minus? It says like this: 100 grams plus 2. If you look at these, products, be it a flour packet, be it a biscuit packet, or be it your curry powder packet, whatever, it has this measurement and plus minus 2. What does this tells you? Sachiro, what does this tells you?
No idea.
Okay. Yanushka, what does this tell someone?
That it could be plus or minus 2. So like it can be 102 grams, it can be 98 grams.
Yeah. So it is a measure of accuracy as well as precision. If it is more, for an example, if it is 100 grams plus or minus 100, it would mean low precision, low accuracy. This this figure tells you that you are purchasing a product with 100 grams, but you can't really measure it to the most granular level, but it can vary plus or minus 2. The precision, right? The similarity. Now, if you do a statistical sampling in a product line where they produce these goods, and if you realize, like your first product is 101 grams, second product is 102 grams, third product is 102, fourth 102, fifth 101, sixth 102, seventh 102. So if you go in this range, everything over 100 for more than 7 or more consecutive times, it's also bad quality, because it means you're consistently delivering something more to the customer than what you should deliver. On the other hand, if it is always 98, 98, 98, 99, 98. If it goes like this also, that means consistently you are delivering, you are not delivering on your promise to the customer. That's also bad. So statistical sampling is done to ensure that one, to see to see the trend in which how you are producing an item, the quality measurements. On top of that, you can't inspect everything, so you take a sample. In a batch of 100, you might take 10 or 2 or 5, depending on the item and depending on the criticality. And then you would examine it to ensure quality. Does that mean you're not releasing bad quality to the market? No, I mean, you might inspect 5 items, those 5 would be in perfect quality. But in the other 95 items, you might have 10 items which are of bad quality, which is released to the customer. But the chances are less, right? I mean, if you have 10 bad products in a random sample, when you take a 10% of that sample, it's possible that you would at least pick a 1. And if you have 1, maybe you would dig deep and you would see, like, okay, there's a bad product. Let me take another set and see. So these are quality control tools and techniques, statistical sampling and inspection. And the other other tool is the approved CR review. So when there is a change request, you need to review it. You need to understand the implications. Okay, fine, customer is willing to pay additional for this additional scope or this change, but what are the other implications? How would it imply it impact my other products? So you need to analyze it. So you need to review your approved CR. So that's also is part of quality control. Any questions on this, guys? Okay. If there are no questions, I can move on to outputs. What are the outputs of quality control? Validated changes. So there are changes that customer has requested and you validate it. So they become an output of your quality control process. Validated deliverables, the end deliverables you are releasing from this point on would be of good quality. That's the output. Change request, even at this stage, you might get certain change requests. Project management plan updates. With the change request, it would have an impact on your project management plan. When your project management plan changes, your project documents will also change. And sometimes you might also change your organizational process assets. You might have additional templates, you might change a particular template, all that. So your organizational process assets would also be updated. So all of these are your outputs for control quality sub-process. Any questions on here so far? Are you all clear with plan quality management, perform quality assurance, and quality control? Shamit, any questions?
All good, Pasindu, all good. Thank you.
All right. Ashen, you're also good?
Yeah, so far so good.
So far so good. Nice. So now I just wanted to spend a couple of minutes on total quality management, okay? TQM. What is total quality management? What do you think is total quality management? According to you, what is total quality management? Janishka, what do you think is total quality management?
I think this is managing and controlling your quality in all aspects, so from beginning to end, not just your product only, your processes as well.
Yeah, exactly. Building in quality from inception to completion. Now, before TQM was implemented, people had a misconception, or people had a People thought quality as releasing a product that meets the requirements. But now today we've gone beyond that. We look at total quality management. We look at how the product was produced, right? Who produced it? Did they have enough training to produce it? What was the accident rate when you're producing it? So quality is built in at every step of the process. That's total quality management. So this concept talks about giving training, avoiding accidents, ensuring ethical practices in producing something, all that, right? So today, more and more organizations are incorporating TQM approaches. With regard to quality management techniques or processes, TQM sits at the center because it ensures overall quality throughout the entire process from inception to completion. And you have other areas which you need to consider. Customer expectations, the voice of customer, how satisfied your customer is with the product. With regard to resource management, leadership, what kind of trainings you are giving, how you are going to ensure right standards of workmanship for these employees, all that. Communication, empowering your people, empowering your employees to do the right thing, to speak up when there are issues. That's also part of it. And continuous improvement, lean beat, Six Sigma, all that talks about continuous improvements, how you can reduce the time to 1 second. So total quality management, it's a very big concept, a large concept which branches out into many different areas, from leadership to customer to continuous improvement to communication, everything, right? So it's important when you're doing a project or product that quality is built in throughout, not just delivering the end product which adheres to the customer requirement, but also you need to see how it was built, in what conditions, where it was built, all that, right? So that's on TQM. Any questions? Any questions on what we discussed today? If you have no questions, that's all I planned for today in terms of quality management. I do have a small activity which I would like you to do in class. All of you can do individually or as groups. We only have half an hour. So what I need from you is to create a network diagram and do a critical path. This is important for your assignment as well. We expect you to do a network diagram and a critical path. So this would be a good exercise for you to prepare for that. So I think half an hour is enough for you to come up with a network diagram. Hiru, can we put them into breakout rooms quickly?
Yes, Pasindu, I'll do it.
Guys, take a screenshot of this screen so that you have it.
Pasindu, group is ready. Shall I open?
Yes, please. Thank you. Can you also make me a host so I can visit the group? Guys, can you see my screen?
Yes,
Yes,
Adibay.
Pasindu.
Okay, so I just did my early start, early finish. I'm just doing the late start, late finish now. So this is also 30. So that's 30. This is 20. So then what you need to do is you need to do a subtraction and see what's the critical path. So this becomes 0, 0, 0, 0, and this was a 0. Here you have float of 5. Here you have float of 21. Sorry, 19. So your critical path is this. So maybe I do this. So it's not that difficult, right?
Yes, first.
Yep. Yes.
Okay, cool. I just wanted you to do this because I just wanted to refresh on this. This is important with regard to time management. This is the most important thing to understand the critical path. So even if you couldn't complete it today, I would recommend you to do it at home. It would be a good exercise for you before the assignment. And for the assignment, I need a manual network diagram. I don't want a Microsoft project diagram. I want something done by you. All right. If you don't have any questions, we can wrap it up. Thank you for joining, guys. Thanks a lot.
Thank you, Pasindu.
Thank you, Pasindu. Thank you.
Thanks, Pasindu.
Thank you, Pasindu. Thanks.
Thank you, Pasindu.
Thank you, Pasindu. Thank you.
Bye.
You.
Thank you, Pasindu.
Thank you, Shamit.